Hi everybody, I am Dr.T. Miranda, Assistant Professor, Department of Computer Science, St. Joseph's College, Kadalur. Today we are going to see about the different states of process and the process state transition diagram. So before getting into the different states of process, just we can have a review about the previous class. In the previous class, we saw about what is by a program, what is by a process, what is by multi-programming, what is degree of multi-programming, and we saw about context switching. Now we are going to see about the different states of process. So basically we are having three states. One is running state, the other one is ready state, and the last one is the block state. More than these three states it's available, which you can see in the later sessions. First, what is this running state? When a process is said to be as running state process. If the process is being present inside your CPU, that is a process which is being currently executed by the CPU, then it is said as a running state process. So running state process, if the process is being present inside your CPU, then it is called as a running state process. Next one is ready state. A process which is not currently executed by the processor and not involved in any I/O operation is said to be in ready state. So a process is in ready state. So when you will be saying it as ready state process means if the process is present inside your main memory. So inside your main memory and it is waiting for CPU. It is not been involved in I/O operation. So the process which is not currently executed by the processor, that is by the CPU, and not involved in I/O operation is said to be as ready state process. The last one is the block state process. What is by this block state process? The process which is involved in I/O operation is said to be in block state process. Normally, a block state process should return to the ready state, then from the ready state it has to go to the running state. Because in the running state, some other process might be executing. So what we have to do is, after the I/O operation has been completed, it has to be moved from your block state to your ready state, and from that ready state it will be going to the running state if the CPU is free. So these are the three important states: running state, ready state, and block state. Running state, you have to remember CPU. So if a process is inside your CPU, then it is running state. Ready state, it is waiting for the CPU. It is not gone for any I/O operation, then it is called as ready state process. Block state, if the process is involved in I/O operation, then it is called as block state process. So now we are going to see about the process state transition diagram. What is this process state transition diagram? The transition from one process or from one state to another state is called as process state transition. Transition of the process from one state to another state. We saw about different states, that is your running state, ready state, and block state. Now we are going to see some other states. So switching from one process to another process, that is changing from one state to another state, is called as process state transition. Now we can see the diagram. So in this diagram, first already we have seen about what is by ready state and what is by running state and what is by block state. Now we are going to see two other states. One is new state, the other one is the terminate state. New state, whenever a new process arrives, it will be directly admitted to the ready state process. This ready state process, so directly we cannot place it inside the CPU. First it has to be admitted inside the ready state. From the ready state, it will be dispatched. Dispatching is nothing but you are going to take a process from the ready state and you are going to place it inside the running state. Then when it is being dispatched, it will be moving from ready state to your running state when the CPU is being free. From your running state, it will be moving to three states. One is the block state, the other one is again to a ready state itself, the other one is your terminate state. When it will be moving to your block state, if there is a IO request, then the process is being moved from the running state to the block state. So already I told that from the block state, it cannot directly go to the running state because the other process might be executing. Now what you have to do is, you have to give a wake up call, that is IO has been completed, and we are going to store the which process has completed the IO. It is being stored in the ready state. From the ready state, again it will be dispatched. So when there is an IO operation, it will be coming to the block state. Next, when the process has completely completed its work, it has been halted or it has been killed, then it will be moving to a state called as terminate state. Then the other state is time up. When this time up state will be used, when we are using a method called as round robin method. In this round robin method, they will be giving a time slice. Each process will be given a time slice. For example, if I am going to have three processes, P1, P2, P3. So P1 needs to be completed within 10 minutes and P2 wants to be completed within 5 minutes and P3 will be completed within 10 minutes. Means each process will be given a equal time slice. Whether it is being completed or not, after 5 minutes, for example, if I am going to give it as 5 minutes, the first process will be executed in the running state. So after 5 minutes, it has not gone for any IO operation or it is neither it is being terminated. What it will be doing is, the time is up, so it will be putting this P1 inside your ready state. So the next process will be dispatched. Similarly, this will be happening. If you are not able to understand here, we can see it in detail about this round robin method in further sessions. Now you can see, when a new process enters, it will be straight away going to your ready state, which you have seen it. When a turn comes, the OS dispatched into the running state. So when it is being dispatched, if it is a new program, it will be dispatched as it is. If it is an old program, it has to load all the CPU registers, because during contact switching, we will be storing the CPU register inside an area called as register save area, which you have seen it in your contact switching. So this CPU registers has to be loaded inside the running state when it is being dispatched. The next one is, the process in the running state will be going to halt state, or you can say it as terminate state if it is being completed. It will be going to block state if the process is involved in IO operation. The process which is in block state goes to the ready state after the IO has been completed. So already we have seen, if the round robin method is followed, then each process is given a time slice. When the time slice for a process is over, it is put in the ready state because it is not waiting for any external events. So now I think you will be very clear about this process state transition diagram. So from the new state, it will be going to ready state. From the ready state, it will be dispatched to a running state if the CPU is free. From your running state, it will be moving to three states. One is the block state if there is an IO request. When it is being terminated, it will be going to terminate state. When the time is up, when the round robin method is used, it will be going to your ready state. From your block state, it will be going to your ready state if the IO is being completed. It will be giving a wake up call. Now we are going to see about the various system calls for process state transition. So admit we have seen it here in the diagram. Have you remembering? Admit. So from which state it will be moving to which state? It will be moving from your new state to your ready state. Dispatch is a system called, it will be moving from ready state to your running state. Halt or kill, it will be moving from running state to your terminate state. Block, running state to block state. Wake up, from your block state to your ready state. Time up, from your running state to your ready state. So that we are going to see it in this system calls. So admit, we are giving a process ID, whichever the process ID is nothing but we are going to give for each process, we will be having an ID. We will be starting from 0. So it can be 0, 1, 2, 3. So which process is going from new to ready state, that is admit. This second one is dispatch process ID. So which process is going from ready state to your running state. Next one is time up process ID. We are going to give running state to your ready state. Block, it will be moving from running state to block state. Wake up, it will be moving from block to ready state. Halt, it will be moving from running to terminate state. Thank you.